Here we are going to discuss the principles of the design of experiments. So what are we going to look at? We're going to look at the planning of an experiment, looking at some definitions of treatments, and then looking at the three principles of randomization, replication, and reduction of experimental error, and lastly a little bit about blocking. So when we're thinking of doing an experiment, we could think of just taking two simple plots in a field and getting some values. A simple measurement is not an experiment, and even a comparison is like this is not an experiment. We need to replicate. So if you have several plots of one particular treatment or variety, that's fine. You've got a single sample or a single experiment with one sample, but in general we prefer to compare some groups. So here we've got 6 of each, and we can do a comparison of yield for variety A and variety B. Thinking about sampling, we're thinking of gaining insight of our sample, and you have so far learnt about means, variances and standard deviations. One value is not enough. We need to sample because we're looking at exploring populations, and we're using the sample to ask questions about something like a sample mean in many cases, and in generally we wish to compare two or more groups. In this case our sample is being representative, or we're considering it to be representative of finding something out about the whole population of that particular item. So what is a treatment? For a particular study we might be looking at something like a breed, if it was an animal, or variety of a crop, and looking at a simple comparison of a new versus previously used varieties. In such a case we would have a single factor trial, and the factor is a categorical variable. This is two or more groups that we might be wanting to look at and we'd replicate. So we can identify the term factor and the treatment within a factor, and these are called levels. If we have two varieties, the factor is variety and there are two levels, A and B. In agronomy we often look at two factors. We want to look at three varieties and 4 fertilizer rates. The three varieties are said to be the three levels of factor 1, and the 4 fertilizer rates are said to be the 4 levels of factor 2. In this case we have a 3x4 study, and it gives us 3x4, which is 12 treatment combinations. There are three principles of design: randomization, replication and reduction of experimental error. Let's just think about randomization. You may have looked at the importance of a simple random sample to avoid bias. We'd like to give every chance we can to avoiding bias and letting every particular animal or plant have an equal chance of being selected or being represented in our study. If we're going to do some comparisons, we have to select two groups, and we have to think of what we're going to use as our experimental unit. Are we using plots? Are we using pots? Are we using animals? Are we using pens? And these need to be selected. So the reason we randomise is to avoid bias. It's an important step and it must be undertaken, and this requires some practical knowledge of the context, which we hope to show in this course. For instance, animals that are allowed to enter the pens without any randomisation might be following a pecking order, and therefore you're going to get behavioural differences among the groups. How can we randomise? We can use Excel to calculate or to give us some random numbers. We can use random number tables found in many statistics books. We can use packages such as RStudio to randomise, or we could do something as simple as writing out the treatments, chopping them all up, placing them in a hat and pulling them out at random. I think you should be able to randomise without using a statistical package, but we commonly do use a package. We replicate. This is the second principle of experimental design. We need to replicate each treatment group. This is so we get a number of samples that will contribute to a mean or a proportion, so that we can have a good representation. So the choice of the number of replicates can be assisted by examining the literature, talking to our colleagues, or conducting a sample size calculation. The size of the study is dictated by resources, by the cost, and the collection of data within a reasonable time frame. Environments may vary, and the application of the treatment and the fertilizer may vary, so we do want to make sure that every independent plot is treated independently, so that this will give us our individual values of yield, milk production, disease resistance, whatever. So this means when you plant plots in a field, they're randomized, they're replicated, and you apply the treatment so that each of the experimental units or each of the plots can be considered independent. So replications can be blocked, and you can typically see in experimental stations that they've blocked their land. It looks very beautiful from the air. And when a study involves producing a crop, the replicates are set out in plots. So very often you have a block of land, and we consider that when a block of land is adjacent to each other, it will be more similar than one that's further away. And this has given rise to the use of the word blocking, and we'll learn more about this under Module 2. This is just heads up. Reduction of experimental error. If we have well-defined descriptions of our measurements, and if we have well-defined protocols such as time, temperature, and under which our study is conducted, and we make sure all our treatments are applied in a consistent way, we're using the same time, the same rate, we want to calibrate our equipment and be aware of any measurement drift. We want to look at our scales, such as rating scales that we might use, make sure we've standardized them for all our assistants and researchers, and we might have to train them. We have to also think about monitoring of the environment, which might be useful, and we should also make notes and comments on our field plans for anything such as pests that may affect our results. So what we've talked about is the fact that 2 values is not an experiment. We're hoping to get very quickly into how do we set out an experiment that is more than 2 groups. We also have to think about blocking and gradients. Blocking we've talked about so far as being spatial, but we can also consider temporal or times of day. We've talked about plots or pots within a glasshouse that can be closer to each other in space, and these have got a more similar environment. Likewise, you can take measurements, and you might do an experiment where you use a time of day as a block, as those measurements that are taken closer or by the same person might be more similar than those taken in different times of day, when we have temperature and other factors that vary throughout the day. And gradients should be considered in any experimental facilities we use. If we're using ovens, incubators, refrigerators, and even storage rooms, their gradients often exist, and the gradient exists in such a way that you can block or you can accommodate this in your experiment. So something like the time of day may matter, because equipment may move or may warm up. Even the operator may matter. If you've got different groups of people doing measurements, make sure you've got that taken into account, because what you can do with your experimental design is to take this into consideration. Here's some pots in a large glasshouse trial, and you have to think about, in a glasshouse, where are the fans, how is this glasshouse being cooled, what is the humidity, what's the light level,